so chapter 23, we are now comparing means. So now we have two different types of data. The confidence interval we build when we compare two means is called a two-sample t-interval. The corresponding hypothesis test is a two-sample t-test. So notice if I want to compare different types of, let's say, I guess, medical brands, I have my generic brand and my brand name. Tylenol versus the generic Tylenol. How do those two things compare? Like always, we have some assumptions with two groups. We want to first look at the independent groups assumption. The two groups must be independent from one another. So one can't affect the other. Also, independent assumption is that the data from each group must be drawn independently and at random. We also have the randomization condition. Our survey is representative of a random sample. Was the experiment randomized? The 10% condition, often don't check this condition for differences of means. We don't worry about it at all for random experiments. So we're going to not look at 10% condition when we're talking about two groups. Also note, we are also missing the success pass failure, which doesn't belong with means. And then we want to have the nearly normal condition. We must check this for both groups. Both groups must have a nearly normal model. A violation by either one violates the condition. So both of those must look normal. There's another term called pool t-test. If we are willing to assume that the variances are equal, we could pull the data for the two groups to estimate the common variance. So as you see here, the variance between these two, so my variance is from here to here, looks about the same between this set of data, right? These are about equal. I could pull this data if I wanted to. These, as you can see, have a completely different variance. You would not want to pull that data. Note, it is never wrong to not pull. So if all else fails, it's safest just to say, no, I'm not going to pull the data. You'll see this because this comes up in the calculator. Do you want to pull or not? Only pull it that when you run the box test or the variance test, that they're pretty much equal or very close. So let's look at an example. Researchers studying the role of internal individual cues and determining how much people eat conduct an experiment in which some people ate soup from bowls that are secretly refilled. The results are summarized in the table. We've already checked the assumptions and conditions and found that the standard error for the difference in means is 2 ounces. What does a 95% confidence interval say about the differences in means amount eaten? So I have an ordinary bowl and a refill bowl. And I want to observe the difference between a refill minus an ordinary. So very important. The first one I want to put in for my 1 will be refill. And then my 2 is going to be ordinary. So how we go about that, which I guess you should all know since you all got hundreds on it, is stats. There we go. Test. Now, with 1 mean, we went to t-interval, right? Now, for 2, we want to go to, passed up, 2-sample t-interval. So, number is 0. If I have data I need to plug in, I want to have my data, but we don't. It already gives us all of our stat information. So I'm going to go to stats, hit enter. This is going to be my first, this will be my second. Because your 1 and 2 is going to work like this. So my mean is going to be 14.7, standard deviation 8.4, and my size is 27. We're number 1. So 14.7 with a standard deviation of 8.4 and a sample size of 27. And my 2 has a mean of 8.5. My standard deviation for number 2 is 6.1. And a standard deviation of 27. Confidence interval, I want a 95% confidence. And pulled, I'm going to go ahead and say no. Like I said, it's always safe just to say no. And calculate. So there we go. My confidence interval is between 2.18 and 10.22. I'm 95% confident that people eating from a refill bowl will eat an average of between 2.18 and 10.22 more ounces of soup than the ordinary bowl. And 95% confidence that they'll eat this much more than the ordinary. That's what that's going to tell me. So nothing else changed here except for what test we're calculating in the calculator. Another type is where we're given data tables and we have to input the data. So judging from the box plot, the generic batteries seem to have lasted about 20 minutes longer than the brand batteries. Before we change our buying habits, what should we expect happen with the next batteries we buy? How much longer might the generic batteries last? What does a 95% confidence interval say with, I want to compare the generic to my brand. So my 1 is going to be generic, and my 2 is going to be brand. So when I put this into my L1 and L2, I'm going to make sure this is L1 and this is L2. Again, comparing my generic with the brand. Let's look at our assumptions. Independent group assumption. Can we say that the brand generic isn't affecting the brand batteries isn't affecting the generic batteries? I would say so, unless they are the same company and one's intentionally making the other one worse. So I would say that's okay. Independence. We can go ahead and let's assume that each battery is independent from one another. Randomized condition. Did we grab random batteries? I don't see the word random, but let's go ahead and assume this. In nearly normal model, looking at the table, would you say that it's pretty close? Yeah, I don't see too much skewed going on. I don't see a lot of big outliers. So we could say that the both are satisfied. Note that if one of these was really skewed, I could not make that assumption. Okay. Now what you want to do is input this data into your table. So stats, edit, and it should look like this. With the L1 being your generic batteries and the L2 your brand batteries. So now I want to go to stats, tests, to sample T interval. And instead of stats, I want to go to data. I want to use my L1 and L2. Keep all that the same, 95% confidence, pulled, always safe to say no. And calculate. So there we go. My interval with 95% confidence is between 2 and 35. I'm 95% confident that the interval from 21 minutes to 35 minutes captures the mean amount of time by which the generic batteries outlast the brand batteries. That's what this is telling us. How long does the generic batteries last than brand batteries? Well, I'm pretty confident it's between 2 and 35 minutes longer. Based on what's going on. I guess they're based on, well, it's not saying what's being done, but I guess they're listening to music. Put them in headphones. How long do those batteries last?